All right, we're going to do lesson 5.6 Inequalities in two triangles. And we're going to apply what's called a hinge theorem. And you should think of this as operating just like the hinge on a door. The further you open the door, the greater the angle of the hinge and or the door in the doorway. And the more you close it, the smaller the angle that it's created. So we have inequalities in two triangles. This time we're actually comparing two separate triangles. So recently we've just been talking about in one triangle. This one we're doing two. And the hinge theorem says if two sides of a triangle are congruent to two sides of another triangle. So in the first triangle we have AB, and in the second one we have FG, and those sides are congruent. And we have AC in the first triangle and FH in the second triangle if we have two pairs of congruent sides. So not the third side, but at least two pairs of congruent sides. And the included angle, included means between the two pairs of congruent sides. So the included angle of the first is larger than the included angle of the second. Then the third side is longer than the third side of the second triangle. So in this case, we're comparing, in triangle ABC, we're comparing the 43-degree angle with its corresponding side BC, and the 30-degree angle in the second side corresponds to GH. Because the angle is greater in triangle ABC, since the 43-degree angle is greater than the 30-degree angle in FGH, that means that segment BC is greater than GH. So I'm going to say if angle A is greater than, and I should say the measure of, we'll fix that. The measure of angle A is greater than the measure of angle F in the other triangle, then segment BC is going to be greater than segment GH in the second triangle. The converse is true as well, and the converse is just where we flip the hypothesis and the conclusion. So if I'm looking at the sides and comparing the lengths of the sides of the two triangles, then the corresponding angles would have that same relationship. So I see that JK is actually less than QP. So the angle associated with JK, which is L, is also going to be less than the measure of the angle associated with QP, which is angle R. And this is, we'll make this a little larger here, less than sign. So if one angle is less than the other, then the corresponding side is also less than the other. At the bottom here, we have just a little example of, a real thing that you might see in real life. We have a car jack, and this particular one is made so that if you spin this bolt here, okay, it's going to either close in points B and C or spread them apart. But AB and AC will always be the same. Those lengths aren't changing, but we're just changing the width of B to C. And so as we do that, the angle is greater. So I'm going to call this actually A1 and B1 and C1 and A2 and B2 and C2. And this will be A3. And we have B3 and C3. And so if I'm comparing all the angles, I see that they progressively get larger as I go from left to right. So that A1 is less than A2, and A3 or A2 is less than A3. So the sides opposite those, which in this case, the side opposite for any of the pictures, the side opposite angle A is BC. So that's going to tell me that Segment B1C1 has a length that's less than segment B2C2, and so forth. So B1C1 is less than B2C2, and B2C2 is less than B3C3. And so if our sides maintain the length, then as the angle gets larger, the opposite side gets longer. Then we're going to try a couple of problems here. It says compare the given measurements. So we're going to look at the picture and you can see that they give us angle measurements, but we want to compare the sides. So we want to compare XW and XY here based on the angle measure. So angle WZX, which is 51 degrees, is opposite side WX, and angle YZX, which is 55 degrees, is opposite XY. So we're going to base our comparison on those angles that we are given. So the measure of angle WZX is 51, and so it's less than the measure of angle YZX. Then so our corresponding sides, those opposite sides are going to have the same relationship. The side that's opposite WZX is WX, and it's going to be less than the measure of XY. So you can see that those relationships are going to be the same. For B, we want to compare the angles, and this time we're given sides, and so we have side BC is 3.6 and side DF is 3, and we want to look at the angles that are opposite those. So the angle opposite BC is angle BFC, and the angle opposite FD is angle FCD. So we're just going to base them on the sides. I see that BC is greater than DF. So the corresponding side to B, or the corresponding angle to BC, is angle BFC. So the measure of angle BFC would also be greater than the measure of the angle FCD. Again, corresponding sides are going to have the same relationship. Greater than, if the one side is greater than the other, then the corresponding angle is going to be greater than the other angle. We're going to apply the hinge theorem here to a word problem. So you really have to pay attention to the wording and what it's telling us. You need to draw a picture. So it says we have two groups of snowmobilers leave from the same base camp. Group A goes 7.5 miles due west and then turns 35 degrees north of west and goes 5 miles. Group B goes 7.5 miles due east and then turns 40 degrees north of east and goes 5 miles. At this point, which group is further from the base camp, and explain your reasoning. So we're going to try to apply the hinge theorem to this based on the picture. You do need to know a little bit about direction here. We have north, south, east, and west, and that's kind of what I'm going to base my picture on. So I have my base camp here. I'll call that B for base camp. Well, I better call it just base here because we have an A group and a B group. So the A group goes west. So from the base, I'm going to go left. Okay, and I'm going to mark off what I'm going to say is 7.5 miles because that's how far they went going to the west. And then at that point, they are going to turn 35 degrees. So we're going to go 35 degrees, and I'm just kind of guessing how much that is. So I'm going to go to 35, and I'm heading now that direction. That's supposed to be 35 degrees north of west, and they went 5 miles. And then my other group, Group B, also went 7.5 miles, but they went due east. So I'm going to try to mark off about the same amount here. So that's going east, and we'll say that was the 7.5 miles there. And then they are going to turn 40 degrees north of east. So obviously 40 degrees is more than 35. We'll just say not drawn to scale here. Okay. And so that's my 40 degrees, and we know that they continued on for 5 miles there as well. What I want to do then is I want to know how far my teams are now from base camp. So what's their distance here? This was Team A, and this one is Team B. I don't actually have to know their distances. I just want to know which one is farther away from base camp. And so I'm going to use my angle measures to help me out. Now I have an exterior angle of 35 degrees, so I want to figure out what this interior would be. And so I take 180 minus 35 is 145. So this angle is 145 degrees. Then I'm going to do the same thing here, and so I take 180 minus 40, and that's 140 degrees. So now I have an interior angle, and I can use that hinge theorem that says that the same relationship these angles have is the same their opposite sides will have. So I see that the measure of the angle that's 145 degrees is greater than the measure of 140 degrees. So that means that the distance or the length of segment A there has to be greater than the distance B is. So that just tells me that A is further from base camp. By the hinge theorem. All right, the next one, it says apply algebra to the relationships in this triangle. And this particular one is asking us for a range of possible values for x. So I see x is actually part of my expression 6x plus 15. And it's an angle measure. And the other angle measure I have is 65. So I need to figure out the possible range of values. This is not the same as the range of values that it takes to make a triangle. We already see that we have one. But what I'm going to do is I'm going to take those angles that I see and I'm going to compare them with the sides. And so angle JHE corresponds to the 11, the side that has a measure of 11, and angle EHG corresponds to the segment that has 9 as its measurement. So based on the rule that the lengths of the segments, the lengths of the sides of the triangle have the same relationship as the angles, that means that since 11 is greater than 9, then 6x plus 15 has to be greater than 65. So I'm going to use that. So and start my equation that way. So 6x plus 15 has to be greater than 65. Okay. Now when I do a range though, that means I'm putting this in between. So it may be greater than 65, but it has to be less than something else. I can't have an angle that's 1,000,000 degrees. So I want to figure out what that is. We don't have to get too creative with that idea. Our 6x plus 15 greater than 65 here. 6x plus 15 is an angle of a triangle. And so we know that the angles of a triangle add up to 180. which means that we can't have any angles that are 180 or greater. So at the very least, it has to be, at the most, it has to be less than 180 degrees in order to have an angle in a triangle. So that's what I'm going to set my limit to. There's no way that that angle can be 180 degrees or more. Now I have what's called a compound inequality that I can solve, because I really have two inequalities in one, and this is going to give me a range of values from smallest to largest that I can have for x. So when I go and solve, since I have two inequalities going here, I'm going to subtract 15 from both sides. And so that gives me 50 is less than 6x, and then another less than sign, 165. And my next step would be to divide by 6 on each part. So I would have x is greater than, this is going to be 8 1/3 degrees, and 165 divided by 6 would be 27 1/2 degrees. So this is my range of values for x. So when I'm doing an angle inside a triangle, if I'm looking for the lowest it can be, obviously it has to be greater than 0 degrees. For the greatest, it has to be less than 180. And then the last one here, find the range of possible values for x. So this time our values come from the sides of the triangle, and we can see that we have two pairs of congruent sides. We have one here and then the 50s here. And so we're looking at the 50-degree angle and the 68-degree angle. The 68-degree angle corresponds to 47, and the 55-degree angle corresponds to 5x plus 2. So if I'm basing my equation or my inequality on the x, I see based on the angle measure, 68 is greater than 55, so 47 has to be greater than 5x plus 2. So 5x plus 2 is less than 47 if I'm comparing their corresponding angles. That means that I have to figure out, well, what's the lowest that it can be? You know, when I'm dealing with lengths, I just know that I can't have a negative and I can't have a 0 length, because I wouldn't even have a segment at all. So that just tells me that my segment has to be greater than 0. Now I have something that I can solve. I'm going to subtract 2. Which gives me 5x there in the middle, 45 on the right, and negative 2 on the left. And then I'm going to divide by 5 all around. A positive 5, not a negative 5. Which gives me x has to be greater than negative 0.4 and less than 9. So there's my range of values. If you are in geometry 2A or 4B, you can stop right there and you'll do the homework assignment that's on the back, page 375, numbers 1 through 7 all. If you are in honors geometry G1 or G3, then we're going to continue to the next page and look at this proof. So I'm going to kind of quickly run through this one. What we have here is really two triangles. We have a triangle here and then another triangle here. And so they do have corresponding sides that match. AD and AB match. And then also, if you look here, we're going to add that AE is congruent to AE. So that's our two triangles. And I'm going to have my statement and my reason. Then I want to start with my given that AB is congruent to AD. And I'm also going to add that, in this case, so that we have triangles that we can compare using the hinge theorem, that AE is congruent to AE, and that is the reflexive property of congruence. Now I'm going to do something kind of interesting, because I have to show that one angle is different from the other, and I really have two angles here with a vertex of A. And actually I have three angles there with a vertex of A, so I'm going to use that idea. And I'm going to use angle addition here. So I have angle EAD plus the measure of angle DAB equals the measure of angle EAB. So that is the angle addition postulate. That's important because if I add two angles and get a third, that third one has to be greater than the two that make the sum. So my next statement is going to be that the measure of angle EAD then is going to be less than the measure of EAB. And that is the definition of inequality. And again, that's because if I add two angles to get a third, each of the two angles that I add has to be less than the whole. And now, since my one angle is less than the other, then the corresponding sides have to have that same relationship, so that ED would be less than EB, which that's the hinge theorem. Okay, that's all for this lesson. You're going to do page 376, numbers 10 through 26, the evens, if you are in honors geometry.